Okay, we'll end at about 9:05, 5 minutes past 9. Okay, so first question here. How is the height, radius and slant length of a right circular cone related to each other? Okay, so very simple warm-up question, shouldn't cause you too much trouble. How is the height? So this is the height. This is the height. The radius, this is the radius. And the slant length. This is the slant length. How are they related to each other or one another? Okay, if you want to be anal about the grammar, okay, it should be one another and not each other lah. Okay, so is it A, binomial theorem? B, Pythagoras theorem? C, remainder theorem? Or D, practical theorem? So is it A, B, C or D? If you're joining us on TikTok, on Instagram, maybe you can give us a comment, drop a comment whether it's A, B, C or D. It's a very simple warm-up question, but sometimes even the simplest of questions people can be stumped. Okay, let's see what answers we're getting from our viewers. Is this PSLE? No, it's not PSLE. This is Wednesday is secondary school. Okay, secondary school. If you're here by mistake, kindly leave. Unless you would like to stay and get your P6 son to learn more about this. Yes, this is Sec 4, 17 carat. This is Sec 4, Sec 3 stuff. Okay guys, help me to like and share the video guys. Thank you. Okay, so is it A, B, C or D? Who can tell me? Let's see, who's lucky, who's the lucky one who's gonna walk away with some prizes? No, there are no prizes today, Sorry, Yes, thank you for liking the live. A, B, C or D, guys? A, B, C or D? Anybody on Instagram? Okay, so the answer is B lah. B. Pythagoras theorem. So to recap, what is Pythagoras theorem? Pythagoras theorem is that thing that you use for right angle triangles, applied to questions involving right angled triangles. Okay, so you can see over here, this is a right angle triangle. Okay, this is 90 degrees over here. So if we were to use Pythagoras theorem here, this would be, okay, let me use a different color. This would be L square equals to H square plus R square. Can you all see that? L square equals to H square plus R square. Okay, the hypotenuse squared equals to the other two sides squared and added together. Like that. L square equals to H square plus R square. Okay, so I hope you all got that. Applied to questions involving right angle triangle. So whenever you see a right angle triangle in trigonometry or in your volume and surface area questions, you know you can apply your Pythagoras theorem. Binomial theorem is something that you learn in A-Maths lah. A-Maths, this one is covered in A-Maths, it's not covered in E-Maths. Remainder theorem also A-Maths. I have no idea what practical theorem is. Okay, maybe it's some other subject altogether. Okay, let's move on to the next question, guys. Volume key formulas, regular versus irregular. Okay, what are some formulas that we can think of? Okay, let's give you all some time to settle down. Maybe if you have a study guide nearby or textbook nearby, you can open up to this chapter. Okay. Usually this would be under the topic of mensuration. Mensuration. Okay. Mensuration. So surface area and volume, some textbooks they call it mensuration. Okay, let's go through some of the formulas here. Okay, let's say we're talking about a cube. Can you all see me? Am I visible? Okay, hi. My name is Coach Nawas, by the way. Okay, I'm going through secondary school maths. So please do me a favor and like and share this video. Okay, let's talk about the most basic of 3D shapes, the cube. So cube. So let's draw a nice looking cube over here. Okay, so you have a cube. What's the property of the cube? The cube has six faces. Okay, it's got 6 faces. 6 faces. And all the faces they're all squares, right? All the faces are squares. So it'll look something like this: length times length times length. Okay, so the volume is L cube. Okay, L cube. Okay, and the surface area, I'm gonna put it as SA lah. SA is surface area. Surface area will be 6L square, because it has 6 faces and each of these faces is a square, and you know that the area of a square is length times length, so length times length is L square. Okay, so that's your cube. This one number 1. Okay, let's use a different color. What about a cuboid? Cuboid. So for a cuboid also you have 6 faces. Okay, but they are not all squares lah. They are not all squares. So how does a cuboid look like? Looks something like this, like a rectangular box. When you buy your shoes, right? When you do your online shopping or you go to the mall and then you buy a pair of shoes, it comes in a shoebox, right? So that shoebox is in the shape of a cuboid. Or your regular brick, you know, when you lay bricks to form a wall, so that brick might be in the form of a cuboid, or usually your brick is in the form of a cuboid. Okay, so again, what is the volume? The volume here will be length times breadth times height. So you have your length, you have your breadth, you have your height, you times all of them together, you get your volume. Then what about the surface area, guys? So the surface area will be 2 times, okay, let me zoom up a bit, LB plus LH plus BH. Okay, because if you notice, guys, this rectangle here, there is another rectangle which is of the exact same dimensions on the other side of the cuboid. Over here. Okay, so on the other side of the cuboid there will be another rectangle which has the exact same dimensions, L times H. L times H. So there's one here, there's one more here. Okay, there's one here, there's one more here. Okay, you all see that? And then there's one on top and there will be one below. Okay, so that's why 2 times L times B plus L times H plus B times H. So this is the formula here, okay? So that's surface area of a cuboid. Okay, let's use a different color now for cylinder. Okay, cylinder. So everybody knows what a cylinder looks like, right? So a cylinder, let's assume that it's a closed cylinder. So that means there's no opening. Over here, there's no opening. This is closed. This one is closed. You cannot fill up the cylinder with anything because all the sides are closed. So for a closed cylinder, maybe I can say that, closed cylinder, the volume is pi r square height. Okay, so this is your r. Okay, this is your h. Okay, what you need to do is you need to find the area of the circular face here, the cross section, and then you multiply it with your height. And then what about the surface area? Surface area is going to be 2 pi r square plus 2 pi r h. All these you have to memorize, guys. You have to memorize all these. Okay? Any questions so far? All okay? Your career is basically doing work that a kid can do. Good. Thank you. I mean, I guess that's a good thing lah. Somebody on TikTok said that my career is basically doing work that a kid can do. Well, I welcome any kids who can give tuition to other kids and make money from it. Okay, guys. Prism. The next one is a prism. Okay, let's see. Today we have 10 people on TikTok. We have 7 on Instagram. Last week we seem to have a lot of people. Maybe because of the school holidays. Now everybody's back to school. Maybe people are a bit tired. Okay, guys. Prism. Prism looks like this. Okay, not prism TV. Prism as in the shape is a prism. Alamak. Okay, so we take the base area times the height. Okay, this is volume. This is volume, V, and surface area is area of all the faces. All the faces. Okay, there's no one formula for all prisms because different prisms have different shapes. Okay, this is also a prism, something like this. Okay, if you were to see this, okay, maybe I zoom in. This is also a prism, guys. This is also a prism. Okay, even though the cross-sectional area looks a bit weird. Okay, let me just color in the cross-sectional area. This is also a prism. And to find the volume of this prism, also same thing. You take the base, which I've colored in purple here. You multiply it with the height, which is this thing here. Okay, HT is the height. Okay, so we've covered a lot. We've covered cube, we've covered cuboid, we've covered closed cylinder, we've covered prism. What else have we not covered? Got a few lah. Got a few. Okay, just bear with me. The next one we're gonna talk about is this thing called the pyramid. So if you go to Egypt, you will see the pyramids of Giza, isn't it? The pyramids. So pyramids, they look like this lah. They look like this. You got 4 triangles all around, and then at the bottom you have a square. Okay, you have a square like that. So the volume here is 1/3 times base area times height. Okay, and the surface area will be the base area plus the 4 lateral faces. Can see? Okay, 1/3 times base area times height, that's the volume. This is the volume, guys. 1/3 times base area times height. This is the height, from here to here. This is the base. Okay, so you take 1/3, multiply the base area times the height, and the surface area is your base area plus the 4 lateral faces. Okay, so that is a pyramid. That is a pyramid. Okay. How many of you all like ice cream? I like ice cream. I love ice cream. Maybe that's why I'm so fat. Okay. If you like ice cream, you might have seen something called a cone. Okay, so cone, let's use a different color for cone. What color shall I use for cone? Okay, hold on. Maybe I can use this orange color lah. Okay, so cone number 6. So we've covered 5 shapes so far. Going on to number 6, this is cone. So cone, you also have a radius over here. You also have a height. And you have your slant length. Your slant length, or you can call it your slant height lah. So the volume of a cone is 1/3 times base area times height. So what do you notice? You notice that it is the same formula as the pyramid. For the volume of a cone, the formula for a cone, the formula for volume is the same for the cone and for the pyramid. 1/3 times base area times height. But the surface area different. The surface area now you must take the base. The base is pi r square plus the curved surface area. The curved surface area. Surface area I put SA. I hope you all understand what SA means. So pi r square plus pi r l. So for curved surface area, the formula is pi times radius times L. This L here. Okay, so let me change this L to from a capital L to a lowercase l, so that you all don't get confused. Okay, this is cone. Cone, cone. Okay, we're almost there. Now we're going to talk about a sphere to end things off, or maybe after sphere I will talk about hemisphere lah. So sphere and hemisphere. So for a sphere, okay, let's use pink. For a sphere, it looks like a ball lah. Sorry, my ball doesn't look very nice. Let me try and draw a proper ball. Okay, so the volume of this ball is 4/3 pi r cube, and the surface area is 4 pi r square, because this ball also has a radius. Okay, if I were to draw the inside of the ball, the inside of the sphere, this is your radius. Okay guys, this is your radius. Can you see that? So zoom in. So this is the sphere. On the inside, if I were to cut the sphere into half, this is the radius from the center all the way to the end. Can you all see that? That's the radius. So this is also the radius. Don't forget. So from the center to the top of the sphere, that is also the radius. Some people get confused. So the radius is here. It can be here. It can be here. It can be here. It can be here. All these lines that I've drawn for you, they are all the radius. Okay. Now finally, we can't end things off without talking about the last star of the show, and that is the hemisphere. So hemisphere basically is 1/2 of a sphere. So it looks a bit like a bowl. Looks a bit like a bowl. Okay, so the volume will obviously be half of this, isn't it? Half of this. So it will be 2/3 pi r cube. Now, will the surface area be half? No, the surface area is not half, because the surface area includes this flat surface. It includes this flat surface. So the surface area is actually 3 pi r square. Okay, so take note. Surface area of a sphere is 4 pi r square. surface area of a hemisphere is 3 pi r square. Okay guys, I hope you're still with me. So here's the formula list. Actually, I didn't have to do all that. Okay, never mind. Here we go. So we have cylinder, cube, cuboid, triangular prism, trapezoidal prism, where the base is a trapezium. Okay, so these are all prisms, guys. These are all prisms. Not prism the TV, not prism the aircon. We are not promoting prism here. Okay, prism here meaning a shape that has a cross-sectional area. So the CSA over here, that is cross-sectional area. So we can also call it the base area. So you take the base area times the length or times the height, you get the volume of the prism. Okay, there the key is over here. Very good, right? These notes, you can get them for free if you're in the Telegram group. See, people do all the hard work for you all. Okay, then we have your pyramid, your cone, and your sphere. Okay, so for the pyramid and the cone, as I said, the volume is the same. The formula for the volume is the same. 1/3 times base area times height. For the sphere or the ball, it is 4/3 pi r cube. Pi r cube. Okay, so join our Telegram group if you've not already done so, guys. Okay, let's go into question 2. The figure here is made up of a right circular cone and a hemisphere. So there are two shapes here. There are two objects here, or this object is made up of two shapes. Okay, a right circular cone and a hemisphere. Find its volume in terms of pi. Okay, so will it be A 12 pi cm cube, B 18 pi cm cube, C 30 pi cm cube, or D IDK? I don't know. What do you all think? Okay, I give you all about 5 minutes. We'll go through this question at 8:35. Okay, give me some time to drink some water. Very thirsty lah, talking about all the formula. A lot of people are asking if this is secondary school or primary school. This is actually secondary school. Okay, this is secondary school live stream. Okay, what is the answer? What do you all think? Is it A, B, C, or D? A, B, C, or D? What do you all think? Ilyas is saying that the answer is C. Okay. Mika is saying that the answer is D, because he doesn't know. Okay. Sure, no problem. Okay, let me pull this behind a bit. UP6, alamak, kesiannya. Okay. Those on Instagram, what do you all think? What's the answer? Is it A, B, C, or D? Okay. You all got 2 more minutes before I go through. Okay, let's get started on this question, guys. It's 8:34. The figure here is made up of a right circular cone and a hemisphere. Find its volume in terms of pi. So what we're going to do here is we're going to find the individual volumes, okay? So to find its volume, okay, we must solve it. Must find individual volumes of the cone and the hemisphere, then add them together. Okay, so that's how you find the volume of a composite figure. This is known as a composite figure because it's made up of different shapes. Okay, so for a cone, we know that the volume, okay, so maybe I put volume of cone. We know that the volume of cone is 1/3 times base area times height. Okay, so 1/3 times, okay, what is the base area for the cone here? Okay, you look closely at the cone, you see that the cone, the base is a circle, right? It's a circle. It has a diameter of 6 cm, guys. So if it has a diameter of 6 cm, the radius will be 3 cm. The radius will be 3 cm. Okay, so how to find the area of the circle? You must take pi r square, right? R square. So the r here is 3, and then you square it. Then you times it with the height. Don't forget the height over here. We have to multiply it with the height to find the volume of the cone. So what is the height? The height is 4 cm. So we multiply it with 4. Okay, so this will give me 3 square is 9. 9 times 4 is 36. 36 times 1/3 is 12. So this will give me 12 pi cm cube. But that is just the volume of the cone, guys. That's just the volume of the cone. Remember, we need to find the individual volumes, and then we need to add them together. We have found the volume of the cone, but we have not found the volume of the hemisphere. So let's go find the volume of the hemisphere. So volume of hemisphere, I'm just going to call it HS because I'm lazy to write the word hemisphere. Volume of hemisphere we know is 2/3 pi r cube. Okay, 2/3 pi r cube. So we take 2/3, we take pi. What is our r cube? Okay, our r for the hemisphere is also 3 cm. Is also 3 cm. You can see the hemisphere and the cone, they both share the same radius. Okay, you all see that? The blue line here. Okay, so it's 3 cm. So 3 cube. Okay, 3 cube is going to give me 27. Okay, so 2/3 times 27, I can cancel the 3 become 1, 27 become 9. This one become 18 pi cm cube. Sorry, I got to borrow from the next page. Not enough space for me. So the total will be 12 pi plus 18 pi. That will give me 30 pi cm cube. I hope I'm not putting you all to sleep, guys. So the answer is C. So those who got C, well done. Congratulations, you've gotten it correct. Okay, those who didn't get the answer, never mind, try harder next time, okay? You all must try harder lah. So it's not 12, it's not 18, it is 30 pi cm cube. Sometimes the exam, they will ask you to leave your answer in terms of pi. So if you need to leave your answer in terms of pi, this is what you will do lah. Easier also, right? No need to multiply in the pi, then have to deal with the significant figures and all that. Very leceh. Okay guys, okay, let's move on to question number 3. Wow, why this question like so complicated? Okay, never mind, I like complicated questions. Okay, the length of each side of a cube is increased by 40%. Increased by 40%. Find the percentage increase in the total surface area of the cube. Is it A, 90%, B, negative 96%, C, positive 96%, or D, 140%? Okay, come, give it a try guys. My time now is 8:39 PM. Okay, we go through at 8:44 lah. 5 minutes time. 8:44 PM we go through. Okay, come, give it a try guys. Okay, so those on TikTok, we have about 15-16 of y'all. What do y'all think? A, B, C, or D? Okay, what do y'all think? How, guys? Mika says he doesn't know. Mika, you're in primary 6, right? Somebody says, I don't quite understand this question. Okay, so, you see, there is a cube. Okay, so you all know what a cube is, right? Cube is got 6 faces. All the faces are square. Okay, then, the length of each side of the cube is increased by 40%. So, when you increase the length of each side of the cube, obviously, the surface area of the cube will increase also, isn't it? So what is that percentage increase? So there is a cube. There's cube A and then there's cube B. There's cube A and then there's cube B. So cube A is the smaller cube. Cube B is the bigger cube. So you all need to make a comparison. So must use algebra lah. Can you draw it out? Can draw it out. Can draw out and must use algebra. Okay, that's why algebra very important guys. You want to do well in your O-levels, your algebra must be very strong. So I will have to use algebra to solve this. No other way. Okay, no other way. Or, I mean, maybe there might be another way, but for me, just use algebra lah. That's the easiest way for me. Okay, maybe for you all, algebra not so easy. But for me, I like to use algebra. Okay, someone is saying the answer is C, 96%. Okay, never mind. We see whether you're correct or not. Wow, you say very easy the question. Okay, good lah. If you say the question is easy, then good. Someone is saying D. This one cannot guess guys. This one you know maths there's no MCQ actually lah. This one we give you all MCQ just to help you all a bit. Okay, so if you use algebra, should be quite easy. Okay, we'll go through in another 2 minutes, guys. I give you another 2 minutes for those who are still doing. Hopefully, you are trying out. Fraction. How do I pronounce your name? Fraction. You say you use algebra. Okay, well done. Tan theta is gradient. What is this fella talking? Tangent theta is gradient. Tangent theta is gradient. Tangent theta is gradient. Oh, you're doing coordinate geometry. Okay, tangent theta is opposite over adjacent. So, yes, actually tangent theta is the gradient. But your coordinate geometry, what? A maths Sounds like you're doing A maths Because for coordinate geometry, to find gradient usually is rise over run. Oh, you're doing A maths. Okay, this one I scared to say anything lah, because to be very honest, I'm an E maths coach. I have taught A maths before, but I think better for me to just focus on E maths. That is my strength. Okay, I do E maths and I do primary school maths. But if you are proficient in A maths, then E maths is nothing already lah. Okay guys, I think 8:44 already. We will go through this question. So the length of each side of a cube is increased by 40%. So what I'm going to write here is I'm going to say let the initial, that means starting, let the initial length of the cube be L. Okay, so the final length of the cube will be 1.4 L. Okay, so if the initial length is L, L here meaning 1 L, guys, 1 L, the final length will be 1.4 L. Why? Because increased by 40%. So when something is increased by 40%, that means you take the original or the initial, you multiply 1.4. You take the original or the initial, you multiply by 1.4. Okay, so the final length of the cube will be 1.4 L. So the cube at the start is like this. Okay, L. The surface area will be 6L square. Agree? 6L square. And then now I make it a bit bigger. So now it will be 1.4L. Can see 1.4, at least 1.4. 1.4L. 1.4L. So my surface area now will be 6 times 1.4 L square. Okay? Alamak, I left my calculator in the bedroom. Hold on guys, give me 10 seconds. Every week I do live stream, every week I forget to take out my calculator. Must be getting old. Okay, so 1.4 times 1.4 will give me 1.96. Okay, so this will be 6 times 1.96 L square. Can you all see that? So this is the new surface area. Initial. This is initial. This is final. Okay. So how to find the percentage increase? So to find the percentage increase, you take the final minus the initial, divide by the initial. Okay. So 6 times 1.96 L square minus 6L square over 6L square. So if you are good in algebra, you know, I can pull out something. What can I pull out? 6L square. So when I pull out 6L square, this one becomes 1.96 minus 1 over 6L square. So this whole thing must times 100%. Okay. So this equals to, can cancel. 1.96 minus 1 is 0.96. 0.96 times 100% will be 96%. So answer is C. Okay, well done to Prakshan, or I don't know, I can't pronounce his name. There was one guy who got it correct. He said C. Okay guys. Okay, I know it looks a bit intimidating, but honestly for myself also, I found this kind of questions to be quite difficult initially. There are two things you need to do here. Number one, you need to be very familiar with naming certain unknowns in algebra. Okay, so this is the important skill that you need to have. You need to be able to do things like this. Let the initial length of the cube be L. You need to write this kind of sentences often. Okay, practice. Then, like from this, you can deduce that the final length will be this. Right? If you can do this part here, guys, I will say half the battle is won already. Seriously. You can do this, half the battle is won. So after you do this, then you ask yourself, okay, what's the initial surface area? Initial surface area will be this. Final surface area will be this. Right? Can I take the 6 times the 1.96? I can, but I decided not to lah. I decided not to. Okay, then the next thing you need to do is you need to memorize this percentage formula here. Okay? So this is final value minus original value over original value times 100%. Okay, the formula might look a bit intimidating, but actually it's quite simple. Okay, and then after that, it's just your manipulation already until you can get this. Okay guys, practice a few times this kind of questions. Look through your 10-year series. That's why you want to prepare for O-levels. You must have the 10-year series, you must have your assessment books, everything must be there lah. If not, how you want to practice? Go and print out all the past year exam papers, assessment books, all everything. Make sure you see, so you go and look for this kind of questions. You go and look for this kind of questions, and then you go and look at those assessment books which provide you with solutions. You try to see one or two, and then the rest you go and try and do on your own. Okay? Don't give up, guys. Don't give up. Oh, that's it. Oh, fantastic. I'm done. Or maybe today I can end a bit early lah. Okay? Who was copying the last one? Sorry. Still copying. Okay lah, let's have a bonus question. Okay guys, let's have a bonus question. By the way, all these notes will be uploaded into the Telegram. So if you're in the Telegram, then you will see my working and all that. Okay, I'm gonna try to look for another question to give you all. This is a bonus question, not included in the original set of notes. Not included in the original set of notes. Give me a minute, guys. Let me take a proper picture of the question. Okay guys, so this is our bonus question for today. Maybe take some time and try and do, and then in a couple of minutes time I'll go through. I'll go through in a couple of minutes time. Bonus question. Only on MasterMaths Secondary School Maths live stream with Coach Nawas. So you join my live stream, I'll try to give you all the goodies. What is the cross section? Okay, the cross section is the shaded part. Oops. Yeah, the shaded part lah. A, B, C, D. Okay, so this is a prism, guys. This is a prism. It has a uniform cross section area A, B, C, D. So the A, B, C, D you can see is a trapezium. It's a trapezium. So how are you going to find the area? 1.3, 1.8, 0.5, 1.3. I think this one might need to use a bit of Pythagoras theorem. Because you need to find the length BC. Okay, so to find this, you might need to use Pythagoras theorem. Okay, let's try. So time now is 8:55. I promise that we will end at 9:05. So let's give this a try lah. Okay. Now calculate the uniform cross section area ABCD of the container. Now this area here is a trapezium. Now what is the formula for area of trapezium? If you all remember, area of trapezium, maybe I write down over here. Area of trapezium is half times sum of parallel sides times height. Okay. Now, where are your parallel sides for this trapezium? AB and CD. Okay, these are your parallel sides over here. AB, CD. Okay, these are your parallel sides. So, where is your height? This is your height. They don't give you the height, so you need to find. So, how to find? You can use Pythagoras theorem. So, you can use Pythagoras theorem. You know that this is 1.3. You know that this will be 0.5. Okay? So let's find the length of BC. Okay? So BC square equals to AD square minus 0.5 meter square. Okay, this is Pythagoras theorem lah. Okay, so AD square is 1.3 square minus 0.5 square. So your BC will be square root 1.3 square minus 0.5 square. So 1.3 square minus 0.5 square is actually 1.44. Okay, you all can try. 1.3 square is 1.69 minus 0.5 square, you will get 1.44. When you square root 1.44, you get a nice number. What is the number? 1.2. Okay, so that's your BC. So now we go back to the area of the trapezium. This will be half times 1.3 plus 1.8, because the sum of the parallel sides you're talking about 1.3 meters plus 1.8 meters. 1.3 plus 1.8 times 1.2. Okay, so key that into your calculator. and you will get 1.86 meter square. 1.86 meter square. So that's part A, guys. Okay, do you all get that? Okay, I'm taking this from an assessment book, so let me just check the answer so that I can confirm that the answer is indeed 1.86. Question. But what did they say here? They want the answer in cm square. My mistake. They want the answer in cm square. So 1.86 meter square is not your final answer. You must change to cm square. So you take 1.86 times. Okay. So very important, you must know that 1 meter is 100 cm. 1 meter square is going to give me 4 zeros. 10,000 cm square. So times 10,000. So times 10,000, this will be 18,600 cm square. Can use your calculator lah. If you're not confident in your mental sums, 1.86 times 10,000, 18,600 cm square. So that's your final answer. Because the question specified that they want the answer in cm square. Okay. So calculate the capacity of the container in cm cube. So now you've gotten the base area, the cross-sectional area. How do you find the capacity of the container or the volume of the container? You take 18,600 multiply this one. Okay, you take the area, the base area, you have found the base area. You multiply it with the length here. The length here is 0.5. So because they want the answer in cm cube, we are going to change 0.5 meters to 50 cm. I hope you all are with me. Okay, give me a few more minutes. I'm ending the session soon. Okay, times 50 cm, because 0.5 meters is 50 cm. So 18,600 times 50, that will give me 930,000 cm cube. And those of y'all who know your volume well, you know that 930,000 cm cube is actually 930,000 milliliters. And then of course you can convert from milliliters to liters. Now it says here the container is completely filled with water to be transferred into cylindrical cans each with diameter 13 cm and height 15 cm. How many cans can be completely filled? So the container is completely filled with water to be transferred into cylindrical cans each with diameter 13 cm and height 15 cm. So how many cans can be completely filled? Well, first we have to find the volume of each cylindrical can. So let's do that. So each cylindrical can has a volume of, okay, so cylinder, the volume is pi r square height. Okay, so the r here will be 6.5 because the diameter is 13, right? The diameter is 13, the r will be 6.5, the height will be 15. So pi 6.5 square 15. Okay, the pi we are supposed to take it as 3.142. Okay, so let's try that out. 3.142 times 6.5 square times 15. This will give me, I get a pretty big number. Not 1991.2425. I don't round off first. Why I don't round off? Because this is part of my working. So I want to make my working as accurate as possible. And then now I take 930,000 divide by 1991.2425. Okay, so divide it by the volume of each can. So 930,000 divide by 1991.2425. You have to be very meticulous in maths.